The Boeing Pelican was a bold concept that reimagined heavy-lift aviation on an unprecedented scale. Designed in the early 2000s, this massive ground-effect aircraft was envisioned to transport staggering payloads of up to 1,400 tons. With a wingspan stretching 500 feet and a length of 400 feet, it dwarfed conventional cargo planes. The Pelican's hybrid capability allowed it to operate both at high altitudes and in ground effect over water, where reduced drag and increased lift would have enhanced its efficiency. Though never built, the Pelican showcased Boeing's ambition in tackling extreme transport challenges, particularly for military and large-scale cargo logistics. Its reliance on ground-effect aerodynamics reflected an innovative approach to maximizing efficiency over long oceanic routes. While the project remained conceptual, it serves as a remarkable example of visionary aerospace engineering, pushing the boundaries of what was possible in heavy aviation. Sixth-generation fighter jets will redefine aerial warfare with advanced technology and unmatched combat capabilities. These aircraft will integrate artificial intelligence for autonomous decision-making, operate in highly contested environments, and feature cutting-edge electronic warfare and cyber defense systems. Stealth will evolve with next-level sensor fusion, ensuring superior situational awareness and survivability in modern battle spaces. Designed for flexibility, these jets may incorporate hypersonic speeds, directed energy weapons, and the ability to switch between manned and unmanned missions. With enhanced agility, speed, and smart weapon systems, they will dominate the skies, securing air superiority for the future. In the 1970s, the Soviet Union sought to expand its energy and resource extraction into Siberia, the far north, and the Far East regions notorious for extreme climates and limited infrastructure. Heavy-lift helicopters like the Mi-6 and Mi-10K played a crucial role in transporting equipment, but their payload limits often fell short of demands. To address this, the MIL Design Bureau, in collaboration with TSAGI, pursued the development of a super-heavy helicopter capable of handling the immense logistical challenges. This vision led to the Mi-32, a tandem-rotor design utilizing components from the Mi-26, with a projected lift capacity of 55 tons for both civilian and military applications. Despite promising research, wind tunnel tests, and positive assessments, the project was ultimately abandoned due to technical and financial constraints. Though never realized, the Mi-32 remains an ambitious chapter in Soviet aerospace history, highlighting the drive for innovation in extreme conditions. NASA is developing a revolutionary X-plane designed to fly faster than sound while minimizing the noise of sonic booms. As part of the low-boom flight demonstrator mission, this aircraft will test advanced supersonic technology that could allow commercial jets to fly over land without disruptive noise. The goal is to provide crucial data that may lead to changes in regulations, making supersonic passenger travel a reality. The aircraft's unique shape prevents shock waves from merging into loud booms, unlike traditional supersonic jets. Instead, it spreads them out, so only a softer sound reaches the ground. To test public reaction, NASA plans to fly it over select U.S. cities, gathering feedback on its quiet supersonic capabilities. The Horten Ho-229 was a groundbreaking German jet prototype developed during World War II, featuring an advanced flying wing design. Created by the Horten brothers, it was one of the first aircraft built to reduce radar detection, making it an early example of stealth technology. Powered by two Jumo 004 turbojet engines, it could reach speeds of 600 miles per hour, outpacing many Allied fighters of its time. Its tailless design minimized drag, enhancing both speed and efficiency. Although the war ended before mass production began, the Ho-229 was captured by U.S. forces in 1945 and later influenced modern stealth aircraft like the B-2 Spirit. Despite never becoming operational, its innovative design remains a significant milestone in aviation history, demonstrating concepts far ahead of its era. Imagine an aircraft with a wing that forms a complete circle around the fuselage, a revolutionary concept known as the ring wing. This was not a sci-fi idea but a real design envisioned by Lockheed. The Lockheed ring wing commercial transport was planned to be 52 meters long, with a circular wing wrapping around the fuselage at a 27 degrees angle and extending up to 23 meters in height. Designed for efficiency, it could carry up to 120 passengers and was ideal for commuter routes that didn't require high-altitude flights. One of the biggest advantages of the ring wing was its aerodynamic efficiency. Without traditional wingtips, it eliminated wingtip vortices, reducing drag and improving lift. This design allowed for shorter takeoffs, lower fuel consumption, and better stability in crosswinds. Though never built, the ring wing remains a fascinating exploration of unconventional aircraft design. The Gyroplane Nisus was designed to offer pilots and passengers an unparalleled aerial experience with panoramic views. Enclosed within a full circumferential frame, its cabin provided both safety and an immersive flying experience. Unlike traditional helicopters, the Nisus relied on an unpowered rotor for lift and a separate propulsion system for thrust, making it more fuel-efficient and mechanically simpler. With its compact design and ability to operate in confined spaces, the Nisus was envisioned for urban mobility, emergency medical services, and reconnaissance missions. Advanced avionics and lightweight composite materials further enhanced its performance and safety. Though it remained a conceptual design, the Nisus showcased the future potential of gyroplanes, offering a fresh approach to modern aviation challenges. The Lockheed C-130 Hercules is a legendary military transport aircraft known for its adaptability and resilience. Since its introduction in the 1950s, it has served over 60 nations in a wide range of missions, from troop and cargo transport to medical evacuation and humanitarian aid. Designed to operate in extreme conditions, the C-130 can take off and land on rugged airstrips, making it a vital asset in both military and disaster response operations. Powered by 4 turboprop engines, the C-130 delivers impressive performance, carrying heavy payloads over long distances with ease. Its durable construction and ability to adapt to various roles have cemented its status as a cornerstone of global military and civilian aviation. With continuous upgrades and modern variants integrating advanced technology, the Hercules remains a critical force in air mobility for the foreseeable future. The Renault Air 4 is a bold reimagining of the classic Renault 4L, designed to celebrate its 60th anniversary with a futuristic twist. This innovative flying car ditches wheels for 4 powerful propellers, allowing it to hover and soar above the ground. Fully electric, it merges advanced drone-like technology with a lightweight carbon fiber body, blending nostalgia with cutting-edge design. With its sleek, angular frame, the Air 4 pays tribute to the original 4L while embracing a forward-thinking aesthetic. More than just a concept, it represents Renault's vision for the future of mobility, one that prioritizes innovation, sustainability, and pushing the boundaries of transportation. The Republic XF-84H Thunderscreech was an experimental turboprop aircraft from the 1950s, infamous for its extreme noise levels. Based on the F-84 Thunderjet, it was designed to achieve near supersonic speeds by combining a powerful turboprop engine with jet-like performance. However, its 3-bladed propeller spun at supersonic speeds, generating an ear-piercing sonic boom that reached over 180 decibels, so loud it caused nausea, headaches, and even knocked engineers unconscious. Despite its ambitious design, the XF-84H suffered from severe vibrations, stability issues, and unmanageable noise, making it one of the most impractical aircraft ever built. After just 12 test flights, the project was abandoned, leaving the Thunderscreech as a cautionary tale of aviation innovation pushed to its limits. The DBA Quiet Jet was an experimental aircraft developed in the 1960s by Douglas Aircraft Company to tackle noise pollution in aviation. Featuring a twin-engine design, it placed its engines above the wings, using the airframe to shield ground observers from excessive noise. This innovative approach aimed to address growing concerns about aircraft noise in urban areas, particularly near airports. While the Quiet Jet showed potential in reducing noise levels, it never advanced beyond the prototype stage due to technical challenges and a lack of commercial interest. However, its design paved the way for future research into quieter aircraft, influencing modern efforts to make aviation more environmentally friendly. The Solar Impulse 2 was a groundbreaking solar-powered aircraft designed to showcase the potential of renewable energy in aviation. Developed by Bertrand Piccard and André Borschberg, this ultralight plane featured a massive 72-meter wingspan covered with over 17,000 solar cells. These cells powered 4 electric motors and charged an advanced energy storage system, allowing it to fly continuously, even through the night, without relying on fuel. In 2016, Solar Impulse 2 made history as the first solar-powered aircraft to complete a flight around the world. This achievement proved that clean energy could sustain long-duration flights and open new possibilities for sustainable aviation. Its legacy continues to inspire advancements in green flight technology. Airbus has introduced a bold new aircraft concept designed to improve efficiency and reduce carbon emissions by 20%. Known as MAVERIC, this innovative design merges the wings and fuselage into a single, aerodynamic shape, minimizing drag while maximizing cabin space. Though currently a small-scale, remote-controlled demonstrator measuring 2 meters long and 3 meters wide, the concept explores future possibilities for commercial aviation. The blended wing-body design not only enhances fuel efficiency but also allows for a more spacious and comfortable cabin layout. A shielded engine mounted above the central body helps reduce noise, while the open interior design could accommodate new propulsion technologies. MAVERIC represents Airbus' commitment to shaping the future of sustainable air travel. The legend of Nazi flying saucers is a mix of history, conspiracy, and science fiction that has fueled speculation for decades. Some accounts claim that Nazi Germany experimented with disc-shaped aircraft, often referred to as Honebu or secret wonder weapons, during World War II. These theories suggest that the Nazis were developing advanced propulsion systems, possibly even anti-gravity technology, to gain an edge in the war. Despite these intriguing claims, mainstream historians and scientists dismiss the idea due to a lack of credible evidence. Most experts attribute the myth to post-war fascination with German engineering, Cold War UFO stories, and sensationalized media. While Nazi Germany did pursue innovative aircraft designs, the idea of functional flying saucers remains firmly in the realm of speculation and science fiction. The Fairey Rotodyne was a revolutionary British aircraft from the 1950s that blended helicopter and airplane technology. Designed for vertical takeoff and landing, VTOL, it featured a massive rotor for liftoff and landing, while twin turboprop engines provided forward thrust in flight. Unlike conventional helicopters, the rotor was powered by tip jets only during takeoff and landing, allowing it to function as an autogyro in cruise mode, reducing fuel consumption. Capable of carrying up to 48 passengers and reaching speeds of 190 miles per hour, 306 kilometers per hour, the Rotodyne was envisioned as a high-speed urban transport linking cities without the need for runways. Despite promising test flights, the project was ultimately cancelled due to noise concerns, funding issues, and shifting priorities. Though never mass-produced, the Rotodyne remains an influential design that helped pave the way for modern VTOL aircraft. The phrase, F-16 Falcons eat hawks for breakfast, highlights the overwhelming superiority of the F-16 Fighting Falcon over the BAE Hawk in aerial combat drills. Developed in the 1970s, the F-16 is a supersonic, highly maneuverable multi-role fighter jet designed for both air superiority and ground attack. Equipped with advanced avionics, a fly-by-wire control system, and a powerful Pratt & Whitney F-100 turbofan engine, it remains a formidable force in modern air combat. In training exercises, the subsonic BAE Hawk, primarily used as a trainer aircraft, struggles to match the speed, firepower, and radar capabilities of the F-16. While the Hawk is known for its agility, it lacks the advanced combat systems necessary to challenge a dedicated fighter jet. The phrase symbolizes the clear advantage that modern supersonic fighters hold over lighter training aircraft, reinforcing the F-16's dominance in aerial warfare. The V-22 Osprey is a revolutionary tiltrotor aircraft, seamlessly blending the vertical agility of a helicopter with the speed and efficiency of a fixed-wing plane. Developed by Bell Helicopter and Boeing, it features twin Rolls-Royce AE1107C engines that enable smooth transitions between hover and high-speed flight. With a top speed exceeding 275 miles per hour and a range of over 1,000 nautical miles, the Osprey significantly enhances operational reach and flexibility. Serving the U.S. Marine Corps, Air Force, and Navy, the V-22 plays a crucial role in troop deployment, special operations, and search and rescue missions. Despite early development hurdles, ongoing refinements have cemented its status as a game-changing military asset, offering unmatched speed, versatility, and tactical capability in demanding environments. During the Cold War, the Soviet Union explored the concept of flying aircraft carriers, massive airborne platforms designed to launch and recover fighter jets mid-flight. Inspired by earlier U.S. experiments with parasite fighters, Soviet engineers envisioned using large bombers or airships as mobile launch bases for interceptors, extending their operational range and effectiveness. One early example was the Zveno project in the 1930s, where a Tupolev TB-3 bomber carried smaller I-16 fighters that could detach in midair for combat missions. Decades later, concepts emerged involving modified aircraft like the Tu-95 or Antonov and Tu-25 deploying MiG-21s. Though no full-scale flying carrier was ever built, these ambitious ideas laid the groundwork for modern aerial warfare innovations, including drone swarms, aerial refueling, and airborne command centers. The Lockheed Cl 1201 was an audacious 1960s concept for a nuclear-powered airborne aircraft carrier, pushing the boundaries of aviation engineering. With an astonishing 1,120-foot, 341-meter, wingspan larger than 3 football fields, it was designed to remain airborne for weeks, refueling and deploying up to 22 fighter jets mid-flight. The aircraft would take off using conventional jet engines before switching to nuclear propulsion for sustained operations, providing global military reach without reliance on land bases. Despite its groundbreaking vision, the Cl 1201 was ultimately abandoned due to immense technical challenges, safety concerns, and impractical costs. The idea of a nuclear-powered flying fortress proved too ambitious even for the Cold War era. However, it remains one of the most extreme and visionary aircraft proposals in history, illustrating the limitless imagination of aerospace innovation. The Philippine Mars' second-to-last flight was a historic farewell to one of the last great flying boats. Originally developed from the legendary PBY Catalina series, the Philippine Mars was among the final operational examples of these iconic aircraft, which had served in World War II for anti-submarine warfare, reconnaissance, and search and rescue missions. This near-final journey was a testament to the aircraft's remarkable endurance, covering vast distances over open water and showcasing its storied durability one last time. As the Philippine Mars neared retirement, its flight symbolized the closing chapter of an aviation era. Once a workhorse of military and civilian operations, the aircraft had evolved into a symbol of aviation history. Though no longer in active service, its legacy as one of the most successful and versatile flying boats ever built remains firmly cemented in the annals of flight.